Sometimes it is convenient to express groups of objects in terms of a certain amount. For example, if you have a pair of shoes, you have 2 shoes. A trio will always contain 3 singers. If you buy a dozen eggs, then you bring home 12. And a gross of pencils contains 144 pencils. In chemistry, we work with a similar unit called the mole. Because individual particles are so small, the number of items in 1 mole is really big. A mole contains 6.022 times 10 to the 23rd particles. It is pretty easy to say that a mole is 6.02 times 10 to the 23rd particles, but really, how big is a mole? Say you have 1 mole of ping pong balls. This would cover the Earth to a depth of about 25 miles. However, when we are dealing with atoms and molecules, we are dealing with extremely tiny particles. For example, if we have 1 mole of water, we have 18 milliliters of water. So a mole is a convenient way to count lots and lots of tiny particles. It doesn't matter what it is we are talking about. If we have 1 mole of things, we have 6.02 times 10 to the 23rd of those things. If we have 1 mole of iron, we have 6.02 times 10 to the 23rd iron atoms. 1 mole of water would be 6.02 times 10 to the 23rd water molecules. And 1 mole of sodium chloride would mean that we have 1 mole of sodium ions and 1 mole of chlorine ions. Let's look at that last example a bit more closely. Ammonia, for example, has a chemical formula of NH3. The formula for ammonia shows that we have a ratio of 1 nitrogen for every 3 hydrogen in each ammonia molecule. So if we have 1 ammonia molecule, then we would have 1 nitrogen atom and 3 hydrogen atoms. This ratio holds no matter how many molecules of ammonia we have. So if we have 2 ammonia molecules, then we would have 2 atoms of nitrogen and 6 atoms of hydrogen. This is still the 1:3 ratio found in the chemical formula. If we make that a dozen ammonia molecules, we can say that we have 1 dozen nitrogen atoms and 3 dozen hydrogen atoms. Again, a 1:3 ratio of our nitrogen to hydrogen. The thing is, it doesn't matter how many moles of ammonia you have. There will always be a ratio of 1 nitrogen atom to 3 hydrogen atoms in your sample. So if we have 1 mole of ammonia molecules, then we will have 1 mole of nitrogen atoms and 3 moles of hydrogen atoms. So we know that 1 mole is equal to 6.022 times 10 to the 23rd particles. What if we have 2 moles? You might be able to easily see that we would need to double both sides of that expression in order to determine that 2 moles would contain 1.204 times 10 to the 24th particles. You might imagine that we don't often work with exact whole numbers of moles in the laboratory, so we would want to see how to set up a conversion. There are a couple of ways to do this. First, we know that 6.02 times 10 to the 23rd particles is equal to 1 mole of particles. So we can set this up as a conversion factor. 6.02 times 10 to the 23rd particles over 1 mole, or 1 mole over 6.02 times 10 to the 23rd particles are our options. Since we want to know particles in our given moles, we would use the 6.02 times 10 to the 23rd particles over 1 mole, so our units will cancel properly. Taking 2 moles times 6.02 times 10 to the 23rd gives us 1.204 times 10 to the 24th particles. We can also look at this as a proportion. On one side of the proportion, we have our particles per 1 mole, and on the other side of the portion, we have our given moles and our unknown particles. Cross-multiplying still gives us 1.024 times 10 to the 24th particles. So let's try a couple problems. How many atoms are found in 0.170 moles of copper? Well, we are given 0.170 moles of copper, and we know that there are 6.02 times 10 to the 23rd atoms in 1 mole. So we would use the conversion factor with 6.02 times 10 to the 23rd copper atoms on top. Multiplying this times 0.170 gives us 1.02 times 10 to the 23rd atoms of copper. What if we want to know the number of moles of carbon in 4.50 times 10 to the 24th atoms of carbon? In this case, we are given the number of atoms, so we would want to flip our conversion factor so 1 mole is over 6.02 times 10 to the 23rd atoms. Here we will take our number of atoms and divide it by 6.02 times 10 to the 23rd to get 7.48 moles of carbon. So the mole is a unit used in chemistry to measure the number of particles present in a sample. 1 mole of particles has 6.02 times 10 to the 23rd particles. This number is so big because the particles are so small.